you Google it? Oh. That's fine. Okay, there we go, future value annuities. Now guys, so far in finance, what we've been doing is, I suppose it is realistic in a sense, but most people don't have like R1 million to just invest at once, and then after 20 years, they get that amount of money back plus interest. And that's kind of what we've been doing so far, right? If we think back to the simple interest formula that we've been using, since grade 9, you learned this formula the first time. It was A equals P bracket 1 plus I times N. What is I? N is also fine. And then the compound interest formula was very similar. It was P bracket 1 plus I to the power of N. Right, now with those formulas, it worked in the way that you are investing an amount of money. That amount of money is fixed in that account for a certain number of years, and at the end of that number of years, you get the amount out. Okay, now some people do that, but I think most people have annuities, which is what we're going to do now, where you actually deposit an amount every month, or every 6 months, or every term, all right, for a fixed number, or for a fixed period of time. Okay, so then with every new deposit that's made, you obviously will be earning more interest. Okay, now remember we did timelines last year in grade 10 as well. Okay, you still need to be able to do all of those. So in the textbook, we unfortunately don't have time to go over those again, but in the textbook, it starts off with questions like that. So chapter 4, I think I'll just make a little note here so that you can actually go look at that exercise. Exercise 4.1, it's 10 questions. So if you feel like you need some reminders on what to do with timelines, because the work that we're going to do now is not timeline work. Okay, so if you want to just go look back at that, it's exercise 4.1 on page 85, and then I have the answers in the teacher's guide if you guys want to take pictures of it maybe. But I think you're fine with it because you wrote on timelines now in your last exam as well. Okay, so I think that's all right. But just in case there is some extra practicing. Now guys, we need to learn a new formula, all right, for future value annuities. So the formula that we're going to be working with, this formula is also on the formula sheet, all right, but it is useful if you kind of know it, of course, and you don't have to go look for it. So it is F is equal to, so the future value, all right, so this is almost like your A value, all right, the accumulated value, the future value of this. We call it a fixed deposit normally, all right, or this annuity. The future value is equal to, then we have a fraction. So it's X and then square bracket, then in round brackets, 1 plus I to the power of N minus 1 over I. Now, the proof of this formula, you don't have to know, but it is done in the textbook. It's quite quick. It basically comes from a geometric series, all right, where every time you invest X, X is the amount of the deposit, the money that goes into the account every month. Every time you invest X, it actually gets multiplied by the interest bracket. You can go take a look, all right? So everything here should be familiar, the I and the N, and that I, right, that's the interest rate, the number of, not years, remember, N is now the number of compoundings, right? So the number of months, the number of whatever, terms or so on, you'll see when we do examples. The only new thing is X, and X is now the payments that are made at regular intervals. Okay, and guys, this is the difference between an annuity question and a timeline question. If we think back to the timeline questions, you can invest a certain amount at the beginning, then maybe 3 years later, you invest another amount. All right, maybe 2 years after that, you take some money out. Then maybe after another 5 years, you invest some more money. Okay, those are not payments made at regular intervals. Okay, so for those types of questions, you will always use a timeline and the method that we've done. When it's regular intervals, so every month, every 2 months, every quarter, every half a year, all right? If it's fixed amounts that are going into that account at the same, at regular intervals, then we're going to use this formula. Okay. Another example of this is like a pension fund, all right? Every month, some of my salary gets deducted and it goes into my pension fund. So this is the formula that would be used to calculate how much money is in there at the end. All right. Well, it is on my pay slip, but I try to not look at that because tax is also a thing that just sneaks in there and takes a lot of it. All right, so let's just do some examples quickly, just on how we are going to use this formula. But it's pretty straightforward, guys. It's just basically substituting in. And then sometimes you might have to solve for X, and in that case, you would just have to solve for it. Sure, now it's a lot of writing. Can I actually just write page 94 and then I'll just, because it's going to take so long. Yes.
Could you also have to solve for N?
Yes, so we're actually doing that later as a separate section, but yes, you could, and then you would have to use logs. Okay, yeah. Okay. They could give you a timeline. Well, I think last year we did actually do these kinds of questions using timelines. So where we said you invest, say, an amount at the beginning of each month because you're saving for like a trip or something. And then we made it X. So you did X and a bracket plus X and more brackets plus X and more brackets. So in this case, we would actually be able to use the formula now. Okay. All right, guys, that is the example. Sorry, I really don't feel like writing that whole thing now. Okay, so Themba invests money into a pension fund starting at the end of January 2016. All right, so end of Jan 2016, let's write that down. I think let's just write down the cliff notes, if you will. So end of Jan 2016. So he pays 1,000 Rand into the fund at the end of every month for 25 years. Okay, so X is equal to 1,000 Rand. And he's paying this at the end of every month. And it is for 25 years. So what is our N going to be? If he's paying it in every month, it's going to be 25 times 12. What is that? I suppose I should know that. But is it 400? 300. Good guess though. Okay, 300. Calculate the total amount of money accumulated into the fund at the end of 2040. All right, so they could have just given us that information. All right, so even if they just told us that the first payment is at the end of January 2016 until the end of 2040, then we need to be able to calculate how many years that would be. All right, now guys, if they're saying that the first payment is at the end of January and the last payment would be at the end of December for that year, right? Because the end of a year is the end of December. Does that make sense? So it would be January, end of Jan, end of Feb, end of March, all right? If you count it like that, it would be a full year. So I don't want you to think that because they're saying, oh, it's at the end of January, that it's going to be one less month. Okay, it is actually still 12 payments for that year. Does that make sense? Okay, the growth of money in the pension fund is calculated at, so now they're giving us the interest rate, is 12% per annum, and then compounded monthly, obviously. Your test, no, the test is just on similarity, proportion, and probability. But your exam is going to include finance. Yeah. Okay, so now, oh, sorry. They're asking for, oh, there isn't actually a question here. It's just that. But I mean, I'm assuming they want to know what the amount would be at the end of 2040. How much money will be in that pension fund? Okay, they haven't actually written that in the question, but that is what they're asking for. Okay, so guys, have they given us everything that we need? We have X, we have I, and we have N. We can find the future value. All right, so let's do that. Future value is equal to, let's practice writing down this formula. Sorry that it's very zoomed in now, but I don't want to zoom in and out the whole time. All right, now we're just going to substitute everything into this formula. So X is 1000. Then we have 1 plus. Now, guys, remember, if it's 12% compounded monthly, it's going to be 12 over 1200. Okay, that's just something to remember. To the power of 300. It's also fine if you didn't calculate that beforehand. If you just write 25 times 12 in your exponent, that's perfectly fine. Then we minus 1. That is all over 12 over 1200. All right, and then if you type that into the calculator, you should get 1,878,846,63. That's quite nice, right? 1,000 Rand every month. 12% is quite a high rate, though. I don't think it's that in reality, unfortunately. Okay, that's basically how you would use this formula. All right, we're quickly going to do one where you have to solve for X. So number 2, and this one is on page 95. Just want to check something quickly. All right, so we even have a little taxi here, a picture of a taxi, okay? They're saying a transport company plans to replace a bus in 5 years' time. The expected cost of the new bus is 900,000 Rand. Money is deposited quarterly into a fund starting in 3 months' time, and the last deposit is made at the end of 5 years. The interest on money paid into the fund is 7.5% per annum compounded quarterly. All right, so we're working in quarters now, right? So four times a year. Calculate the amount of money that they need to deposit quarterly so that the company will have sufficient funds available at the end of 5 years. Okay, guys, what do we want the future value to be here? What do we need, or what does the company need to replace the bus in 5 years' time? 900,000. Okay, so the future value here is actually given. It is 900,000 Rand. Obviously, they are wanting us to solve for X. Okay, they're saying calculate the amount of money that they need to deposit quarterly so that the company will have 900,000 Rand available. Now, at the end of 5 years, so that means that N is 5 times, how many times a year will they make a deposit? 4. So that will be 20 deposits altogether that they have to make. The interest rate is 7.5% per annum. I'm just going to say comp. I think we all know that that means compounded quarterly. Now, guys, usually if the payments are made quarterly, they'll give you a quarterly interest rate. Okay, morning. They do have to correlate. Okay, cool, thank you. They do have to be the same. All right, so the the period of the payments has to be the same as the, what's it called? The compounding time. Sure. Sorry, it is still a bit early. Do you guys understand what I'm saying? All right. Now, what do you think you would have to do if they say that the payments are made quarterly, but they're giving you a monthly interest rate? Is there a way to convert a monthly interest rate into a quarterly interest rate? Not necessarily. You can't just, yeah. Do you remember that we had a formula last year? Was it last year that I taught you that formula? Of going from an effective interest rate to a nominal interest rate. All right. Now, guys, if it's quarterly to monthly, that's actually nominal to nominal, which you can't do straight away. So you would have to go quarterly to effective and then effective to monthly. All right. Which would be not a lot of fun. I mean, it would take a long time, but it's not that bad. Okay, I'll try to find an example like that somewhere. I haven't actually seen it being asked like that in a test or exam, but I just want to alert you to that. I mean, it is possible. Okay, we could ask you something like that. So this must correlate always. If not, you're going to have to convert. Okay. All right, what are we doing? I just quickly want to discuss this time period that they're talking about because they made it sound a bit confusing. Hey, they're saying money is deposited quarterly into a fund starting in 3 months' time, and the last deposit is made at the end of 5 years. Now, let's just think quickly because all that we actually need to know is how many payments are made per year. Now, if the first payment is made in 3 months' time, do we agree that that is at the end of the first quarter of the year? Right? Say we're at the beginning of January now. In 3 months' time is the end of March. That is the end of the first quarter of the year. All right, so that's one payment. Then the next payment will be 3 months later. All right, end of the second quarter. Next payment will be 3 months later, end of the third quarter. And then the last payment in that year would be at the end of the year. So that does give us 4 payments. Okay. So I don't want you to get confused with this whole thing where they're saying in 3 months' time, all right? They're basically just saying that you're not making a payment straight away. Making your first payment at the end of the first quarter, but then you are still making 4 payments that year. Okay, let's quickly work this out, guys. Now, because we're solving for X, I prefer to write this side on the left. Okay, you guys know that I like what I'm solving for to be on the left, but it doesn't really matter. I'm going to say X. It's up to you. It's personal preference, I suppose. I'm just writing the formula down again. No, you don't have to even write it down once because it's on the sheet, on the formula sheet. I want us to get used to it. Okay, now I'm filling everything in. So we have 7.5%, but it's compounded quarterly. So we would have to say over 400 to the power of 20. Again, it's fine if you write 5 times 4, then minus 1. That is over 7.5 over 400. And that is equal to the future value, which they told us is 900,000. Okay, now guys, if you have to solve for X, what are we going to do here? What are we going to move first? Denominator, and I'm going to times by it, right? So this now, you actually don't have to write any of these in between steps. You can literally just go straight from this to the answer. But let's just write it down just so that we know when we're actually solving this, what we're doing. Yes, yeah. So you would multiply by the denominator, and then whatever answer you get there, you're going to have to divide by this whole bracket. Okay, so you can do that all in one step. Let's just write it down as the first example, then you never have to write it down again. Okay, and then that would give you a value. And then to get X, you would just take whatever this is and you would divide it by that bracket. Do it quickly and let's see if you get the correct answer. Right? Did you guys get that? Okay, so that's quite a big deposit to make every 3 months. Okay. Now, guys, something that I want you to notice about the two examples that we've done now so far is that in both cases, the first payment was made at the end of the first time period. Okay, in the first example, I'm going to just read the one line that is of interest, the one about Temba investing money into a pension fund. It said he pays 1,000 Rand into the fund at the end of every month for 25 years. All right. This one that we did discuss it already, but they said money is deposited quarterly into a fund starting in 3 months' time. All right. Now, in reality, that's also not really what happens. Okay. Normally, if you open like a savings account, you're going to make a deposit immediately. Okay. So this formula that we've been working with only works if the payment is made at the end of the first time period. Okay, let's add that in. I don't know if this pink is going to work now. Let's see. First payment made at end of first time period. Oh, I'm sorry. That's actually off screen. Okay, so we're going to have to think of what happens when we make the first payment immediately. Okay, which is what's going to happen in the next example. So for number 3, I want us to actually write this example down because it is important. So let me just zoom out again. Right, so example 3, it is in the textbook, but we are going to just write it down. I'll condense it a bit so that it's not as much writing. guys, I want us just to draw a timeline for this one, just to figure out, because we're going to have to make a change to the formula. All right. So I just want us to think about what is actually happening in this situation. So there are 12 payments, right? So I'm going to do 12 lines, T0. Oh, I actually have one too many. I just added an extra one. Oh, right, T0, 1, 2, 3. Oh, okay, no, that is fine. You actually need 13 lines, okay, because you're starting at T0 now for this one, not T1. Now, I actually want us to compare what would have happened if we made the first payment at the end of the first semester, I suppose, half a year, versus at the start. Okay, because that will help us to figure out how we need to change this formula. So if payments were made at the end of each month, right, then we would, not month, sorry, I keep thinking month, but at the end of each 6-month period, then your first payment would be made at, because now these don't represent years, okay, these represent half years. Does that make sense? Right, so T0 is the beginning of the whole 6-year payment. This is the end of the first 6 months. That's the end of the second 6 months, so the end of the first year. Okay, does that make sense? Maybe I should just add that in, sorry, because that's different from what we've done before. This is end of first 6 months. Okay, and then so on. So each block represents 6 months. So if he was making his first payment at the end of the first 6 months, it would be here, right? I'm just going to put it as X. We know that it's 30,000, but I'm not going to fit 30,000 underneath each line. Okay, so X, the payment that he's making. Then, so that would be the first payment. So guys, is he earning any interest in this first 6 months? No, because he hasn't actually invested anything. All right. Then that would be the second payment, third, fourth, fifth, 6, 7, 8, 9, 10, 11, and 12. Okay. So that would represent the whole investment period. So no interest for the first bit, for the first 6 months. Now what's actually happening in this case is that the first payment is made immediately. All right. Then the second payment, third, fourth, fifth, sixth, and so on. Is he going to make another payment at the end of the time period if he's paying at the beginning of each 6 months? Not, hey? So he's still making 12 payments altogether. It's written there. Decides to make 12 semi-annual payments of 30,000 Rand into the account starting immediately. But what I want you guys to notice is that in the second example, or the second row here, and what is actually happening, he's definitely going to earn more interest than in the first case. Is that clear? How much more interest will he earn? What do we think? 6 months more interest, hey? What do we think? Well, if he makes the final payment here, then the money is paid out immediately. So he's not going to earn any interest here. It's still 12 payments, right? So he's not making more payments than he normally would.
An extra 6 months and just a whole 12 payments.
Yes, exactly. All right, so he's making the same 12 payments, but each payment is made 6 months earlier than it would have. So every single payment is going to earn 6 months more interest than if he had made the payment at the end of the month. Right? Does that make sense? The first payment is earning an extra 6 months worth of interest. Because this first payment was going to earn all of this interest anyway. Right? Remember, each payment is in that account and earning the interest for however long it's in there. All right? So every single payment is going to earn 6 months more interest. So what we're going to do is we're going to have our normal formula, but then we're going to have to times it by 1 6 months worth of interest bracket, basically. Let me show you how that works. Okay, so we're going to have our F equals our normal formula Yes. So we are just going to do this basically. I'm going to multiply it by 1 interest bracket. Right?
So the reason we're assuming it's paying at the start of the month is that just because of it saying start of the year.
Yes. Yeah. So the wording is very important because they said starting immediately.
So usually when we do this payment stuff in the future, it would be like at the end of the month.
Well, they did say in the previous 2 ones, but yeah, so the basic formula is built on the premise that it's paid at the end of the first period. Yes.
Sorry, could you please just explain again why?
I will. Let me just show you this. This is actually maybe a more understandable way of writing this formula. It does come out to the same thing, but how's that? If we actually take our X value and we make it 1 time period worth of interest more, and then we put it in the whole thing. It is the same thing, yeah. So here, Georgia, each X payment, each amount is made 6 months earlier than it would have been. So each payment is earning 6 months more interest, 1 time period more interest than it would have if the payments were made at the end of the 6 months. So we make each payment 1 time period more. Right, does that make sense? Grace? No. This formula is not on the formula sheet, and this is the one that you need to always use if the payments are made at the beginning of the month or the 6 months or the quarter or the year or whatever the period is. Yes. Okay. Yeah, so all of them. So in the end one, the last X wouldn't earn any interest, but in the start one, the last X earns 6 months interest. So guys, does it make sense that every payment is in the account for 6 months longer if it's paid at the start of the time period as it would have been if it's paid in the end? All right, so this extra bracket now that we're putting in and that we're multiplying by, if we use the second formula, we're multiplying X by this bracket. So it's almost like the end amount is just X times 6 months worth of interest, or X with 6 months worth of interest added to it. Right, in a sense. Okay, so this is the formula that we need to use. So this is when the first payment is made immediately, Or sometimes they won't use that word. Sometimes they'll just say payments are made at the start of each month, or yeah. So or at, let's say beginning of each time period. Okay, and like I said, this formula is not on the formula sheet, so you need to be able to basically change the original, the given formula to this. Okay, so we are quickly going to work this out. We're going to figure out what, or we're going to calculate the actual answer here. So X was 30,000. But now we need to put one interest bracket there first. So 1 plus 7.5 over 200. And then we use our formula as usual. All right, so now N here is going to be 12 because it's 6 years times twice a year. Minus 1. And then if you work that out, you should get an answer of 461,027 and 10 cents. Yes. This first one. No, because this is a 6 months worth, because each 6 months is one time period, one N. Not one N, one payment. Okay. If this was monthly, then yeah. Okay, any questions, guys? Okay, I think that is it for today. Yes, I'm just going to give you some questions from the, not many, just 1 or 2 from this exercise to practice. Okay, so number 2 and number 6. I think to start that now, you can finish it in the 9 minutes that you have left. Then you don't have to worry about it again. Yeah, it's just very small. Let me send it on the group.